Magnetic braking is a type of braking which doesn't rely on mechanical pressure, as is common in most braking systems. We'll demonstrate this type of braking tube. If we look down on the copper tube as the magnet falls through it, you can see that the magnet never touches the sides of the tube. Therefore, friction cannot have a role in the magnet's deceleration. Using the following cartoons, we can explain the processes that are actually happening. Again, we see the magnet dropping through the tube. The red lines are added to represent the magnetic field produced by the magnet. As the magnet falls, the magnetic field in the copper tube changes. This variation in the magnetic field induces an electric current, as predicted by Faraday's law. Faraday's law states that any change in the magnetic environment of the copper tube will cause a voltage to be induced in the tubing. This induced voltage creates electric currents in the copper called eddy currents. They're called eddy currents due to the circular motion they undergo. All electrical currents produce their own magnetic fields, which are illustrated in this diagram by green lines. Another law predicts the direction these induced electric currents and their magnetic fields will flow. This is called Lenz's law. Lenz's law states that when an electromagnetic field is generated by a change in magnetic flux, according to Faraday's law, the polarity of the induced electromagnetic field is such that it produces a current whose magnetic field opposes the change which produces